Good afternoon to all of you. Uh, Now we will discuss just a summary of the last class. Then we will go for the today's class. In the last class, we discussed about the syllabus, about the unit 5, the syllabi of unit 5. And the next we discussed about data acquisition system. I told to you that the data acquisition system is, it captures some physical parameters from a machine or a device or an equipment, and then it sends to the system through data acquisition system. Inside in the data acquisition system, that means what is happening. The first here, the physical system is there. The next step is a transducer, sensor or transducer. And the next step is a signal conditioning. That means the output of the transducer is an electrical signal. Here in the signal condition, it makes the signal correct. And then it enters into the A to D converter. That means A to D converter means analog to digital converter. And next step is the computer. That means in the computer or in a display device, it is a monitor. That means here from the physical system, the parameter is analog. From this analog, we are converting into an electrical signal through transducer. And then next, that electrical signal, we are making it, if there is any error, we are making it correct through signal conditioning. And then we are sending into that signal into the analog to digital converter. There, the digital output of the A to D converter is a digital conversion. That digital signal is visible in the display or in the computer. That means here in the analog, for example, pressure device. Here in the pressure device, we are noting down that through manually 4.2 Newton per millimeter square. But in the digital, it will display. Here in the physical system, some indicator is there. In that indicator, with the help of the divisions, we are finding out the value. Example, I told to you watch, analog watch, digital watch in the beginning of the class. And then next here in the digital, what happens in the computer or the display, it will, the number indicates correctly with accuracy. That means, for example, in the pressure 4.2 Newton per millimeter square, but here we can identify 4.234 Newton per millimeter square correctly. So here there is no division, directly the new display in the numerical number, right? And that means here from the physical system, that is, or the equipment or a machine, whatever the output is the physical variable, that variable sends to the data, that means data acquisition. Here the data acquisition system, in the data acquisition system, what happens? A signal conditioning, analog to digital converter. That means the data acquisition means here in the data acquisition, here whatever the physical variable from the equipment or a machine, that variable sends to the data acquisition system. Data acquisition. In the data acquisition system, what is there? Signal conditioning, ADC converter. That means analog to digital converter or digital to analog converter. These three is there. And then the output of this one is a display device. So here again, I'm repeating off here. In the last class, what we are discussing about data acquisition. The data acquisition system, what is the process here? What are the signal conditioning is there? The signal conditioning already we discussed in unit 2. What are those signal conditioning? Amplifiers, filters, attenuators. These are all the signal conditioning. And the next is analog to digital converter and digital to analog converter. That is it. These three things is nothing but the process of three things is nothing but data acquisition. Today, we are going to discussing about analog to digital conversion or digital to analog conversion. Signal condition, why? Because again, I'm repeating, all of you listen clearer. Somebody is not, some of them, they are not concentrating well in the online classes. This is not good. And also now the strength is very less. Better intimate to your friends faster. Already I posted the message in the WhatsApp group. So all of you join at 2 p.m. Right? The next, see here, the data acquisition, what is their signal conditioning, analog to digital conversion, and also maybe analog to digital conversion according to our requirement, or the combination of these two, analog to digital conversion or and also digital to analog conversion. These things. Already signal conditioning, already we discussed in unit 2, so we are not able to discuss that one. And now we are going to discussing about analog to digital conversion and digital to analog conversion, right? Then this data acquisition system will complete. So last class we discussed the things, right? Then next, today we are going to discussing about analog to digital conversion or analog to digital converter. We can also call it as analog to digital converter. And also we can call it as analog signal to digital signal. The conversion of analog signal to digital signal. And DAC means digital to analog conversion. That means digital, that means data converter. Here the data converter. Here ADC means data converting from analog to digital. DAC means data converting from digital to analog. Or we can also call it as a digital signal is converted into analog. The next here these analog signals. That means analog signals is a ADC means analog signal to digital signal, the conversion of analog signal to digital. That means the data converting from analog to digital. See here, in this analog signals, examples and applications, many more. See here, microphones. All of you see. Now take your voice varying pressure waves in the air and convert them into varying electrical signals. See here, so taking, that means our voice as input. Voice as input. That means it is under the, that means here I am talking means the pitch is varying. Pitch is varying means automatically word to word, the pitch is varying. So that means here varying pressure waves in the air and convert them into varying electrical signals. Examples, there are so many examples out there, the analog signals. And seat belt, right? And thermocouple. Thermocouple means here the temperature, all of you know the temperature measuring device converts thermal energy to the electrical. Here I am saying, for example, all of you know the thermocouple. Here a temperature measuring device is a thermocouple. It converts the analog signal. Analog signal is nothing but temperature measurement device with the help of the some so and so. For example, thermocouple is actually a sensor. Other temperature measuring device is a thermometer. When you dip in the thermometer, whose temperature has to be measured, whose substance temperature has to be measured. So we have to go through that analog, right? Here the mercury is rising. So on the here corresponding scale, we are note down the readings through manual. It's maybe a somewhat, of course, maybe right approximately. Sometimes the divisions will be changing, so automatically the calculation we can, that means approximate, you can get approximate, but you cannot get accurate. But in this, with the help of the thermocouple, whatever the temperature, physical, here what is the physical variable? Here temperature is the physical variable. So that is convert, that means that is nothing, thermal energy means is nothing but temperature. That temperature analog signal is converting into electrical signal, right? That electrical signal, the output of the electrical signal is a from the transducer, right? That transducer is nothing but here. What is a sensor or a transducer is thermocouple. So that means the output of the thermocouple here is an analog form. That analog form we are sending through signal conditioning and the next ADC conversion. Lastly, we can get ADC conversion is analog to digital conversion. Then only lastly we can get the digital 42.53 degrees centigrade. It is displayed in the board. So now are you understanding? So voltmeters, same. So of course, already you did some experiments in the BEEE lab. There some voltmeters are there. Analog, we can note down the readings. But that signal is the input. That one, this is directly. Voltmeter is nothing but a voltage. That is nothing but a electrical voltage signal. Sending to the where we have to send to the signal condition, and then we have to send to the A to D converter. Lastly, A to D converter means the output of the A to D converter is a digital only. Analog to digital. That means analog signal of an electrical signal is converting into a digital signal. And the next one is digital multimeters. These are all the examples. Digital, of course, you can see, for example, the two positive and negative terminals are there. For example, in the household, for example, in the plugs, there is electrician, that means technician will come, electrical technician. Then he will put that that means volt multimeter. When you press that the pins in both positive and negative, then automatically the indicator will be. That is analog. Now with the digital, already in our lab, mechatronics lab, digital multimeter is available. Mechatronics lab. Mechatronics lab, digital multimeter is available. Right? All of you can see it. The next, this is ADC and DAC. Analog signal to digital signal. And next, digital to analog signal, according to our requirement, we have to go for conversion. See here, this is the physical variable. All of you see here. See here, this is physical variable from an equipment under test or a machine, right? Physical variable. That is here the transducer. It is the input to the transducer. Means the transducer, that signal, the physical variable, that signal is the input to the transducer. It converts the other signal, that is electrical signal. That is in the form of an analog input. It is analog, that is analog signal. Electrical is an analog signal. Always the analog signal, see, this is the analog signal. Right. I told to you the digital signal. What is the digital signal? It should be like this. I told to you in the last class. It's the digital signal. This is the analog and this is the digital signal, right? Here, the analog input is sent to the analog to digital converter. Here, the data converts, and then these are the digital inputs, right? To here, this is the output of the ADC, and the digital system here is a computer or display device, right? Display. And again, here the output of this ADC is a digital. This is a digital one. This is a digital. This is a digital, right? And of course, some according to our requirement, we can go for up to this level only, digital system. Monitoring of digital in the form of numerical number, the variable, physical variable. Here, whatever this physical variable, we can obtain here in the digital system computer in a digital, that is numerical number. We need to convert that digital again into analog to some applications. So again, that's digital signal. Why? Because to get accurate, you have to go for. And that means why here this is going up to some parameters only for reading, note down the readings up to this one. Why we have to go for this one? The next level means to get the output motion where in the industries, where the process is going on to get the required output. So for that, we have to go for again digital to analog conversion. See here. Now this is the digital input to the, this is the DAC. That means uh, converts, this is the digital signal. From the digital system, the output is a digital signal. That signal is the input to the DAC. That is a digital to analog conversion. The output from this DAC is an analog output. Here, why is here we are giving analog input and we are getting analog out? What is the benefits? So this is actually why we have to go for further DAC also, analog to digital conversion. Next, we have to go for digital to analog conversion also again. So why we have to go in the industry to move any part within a particular distance? So here we have to go for the signal to make it correct through this ADC and DAC. Then only we can get the signal, correct output signal, and then the movement is also perfect, accurate. And then this digital to analog output, this analog output is the input to the actuator. So the actuator activates perfectly. Actuator actuates perfectly the movement. So to control the physical, that means why we have to go for a DAC next step means to control the physical value. To control the physical value. See here, to control the physical value. See here, already I told to you that a closed loop control system, right? That means in the closed loop control system means to get our output, the feedback element is there. In other words, the feedback element, all this maybe a feedback element is sent to the error detector. From the error detector, the next step is controller, microcontroller. We can also go for this one also. This total data acquisition system also we have to implement there. Then we can get the output physical variable correctly. That means controlled. You can control that physical variable correctly. మీకు ఆల్రెడీ చెప్పున్నాను మనం గుర్తుందో లేదో మీకు మర్చిపోయారేమో యూనిట్ 1లో మనం ఆల్రెడీ we discussed about the open loop system and closed loop. Here error detector is there, right? మర్చిపోయారా plus minus. Here the plant is there and here we can get the output, right? If the output is not our required output, then we have to go for feedback element, right? And the next here, right? This is the input, right? Here, this is system. This is a system. Here we have to place this one total apparatus. Then we can get the correct output. That means control. We can control the physical variable in the closed plant, any. You can control the physical variable correctly. That means, for example, take the single acting cylinder, double acting cylinder. Here, the piston is moving forward, right? Piston is moving forward. I need that a piston has to move only, for example, 20 centimeters or constraint, 25 centimeters it has to move. So in that I have to, the pressure, the compressed air pressure should be correct. If it varies automatically, this 25 centimeter distance also varies. The piston movement varies. So for this, we can get the this analog output correctly. That is the pressure, the air compressor pressure. We have to automatically it will set, and then the compressed air it will send to the cylinder, and then the piston moves forward direction. So this should be correct. This should happen correctly. So with the help of this, that means we can get correct time. Once if it moves 25 centimeters, the piston moves forward 25 centimeters correctly with that pressure, then automatically what the piston pushes the product, this product, some particular distance. If it varies, the pressure varies automatically, the distance also varies, thereby the product also will not move correct location. That is, these are all the things. To minimize all these errors, we have to go for DAC, data acquisition system, DAS. The data acquisition system, what are there? Signal conditioning is there, analog to digital conversion is there, and digital to analog conversion. I told you up to this point, this one we can also use. Up to this point we can also use. All of you see here to this point. That means physical variable, transducer, ADC converter, and then in digital system we are getting. That means what in the last previous, right? That means okay, right? This up to this one you can get in the monitor, right? Right. But see here, that one we have to note down the parameter, whatever our according to our required form. But in this is again in the industries we can go for a required movement, and then some required process is going on. Then we have to go for the analog. Then again digital to analog conversion, and then again the output of the analog output is the input to the actuator, so that the system activates, or it activates it, or it controls the physical variable correctly. Now you got the point. Do I know? How you understand? Next. See here, next. So analog to digital conversion. We'll go for analog to digital conversion. Right? See here, this is, I told you, this is the analog signal, right? This is the analog signal. See here in this, if you see clearly, this process is nothing but periodically sampling the analog signal. This diagram is very important. We have to draw. I already in the last class the variation I clearly shown to you in the figure. See here, this is the analog signal. See here, first one sample and hold. See here, when it in wheels, when it touches, automatically some of the analog signal is sample of the analog signal and hold circuit, it holds that analog signal. So by showing, so and then next this is nothing but with respect to time, and here the voltage, the electrical signal. That means electrical voltage is the signal, that is the, this is on y-axis, and time with respect to time is on x-axis, and this is the analog signal. It is converting into this form, right? And then next to what I told to you that it is converting like this, right? Right, it's converting like this, right? It's convert like this. It is converting. This is the digital signal. This is the analog signal, and this is the digital signal. In between this, it is this sampling. That sampling signals will go like this. The switches closes for the small part in t seconds for every clock period t. Like this will be obtained in the some oscilloscope is there. We can observe clearly all things. Some electronic devices are there. And B is this nothing but it is the input to a signal waveform, that is analog, and sampling signal. Just this is a sampling signal, just for the in which way that analog signal is converting into a digital signal. First step is this is the analog signal, and then it is converting into this form the signal, and a digital signal is converting in this form. Sampling signal. The C is the sampling signal, right? Control signal for the switch, and the output signal is A to D. That means output is the digital is the output. This is the digital signal, and this is the analog signal is the input signal. Of course, now you got the point that the signal conversion, in which way the signal is converted. This is the first analog signal, right? Right. This is the analog input signal waveform. That is nothing but input here. It is analog to digital. That means analog. Analog signal is the input, and the output is the digital, right? Output is the digital. So here the output signal is there. In between the sampling signal is this is in this form, right? Now you got the point. Next we will go for Here this is A to D converter. That is converts analog signal into binary bits. That means digital is binary, right? Digital is binary, the form of binary 0, 1. Already last class I shown diagram. This is the input diagram, analog signal, same sample and hold, and converted into the means here. If you see in the previous sample and hold, you see is nothing but sample and hold. See here, this is sample and hold. A is a sample and hold circuit. So when it touches this one, automatically some of the sample will hold, some of the analog signal will hold. That means analog signal, it is nothing but it is continuous form, like this continuous form like this. But with the help of this one, we can for visible and for understanding purposes, we have to go for sample and hold circuit. This is the sample and hold circuit, right? So from this, so we can get that wave. It is in the form of this, the output of this one. So that is nothing but the input signal waveform. Sample and hold, right? Sample and hold means this is sample and hold, right? Sample and hold, right? Sample and hold. This is sample and hold. A clock signal. So from this output is a clock signal. What is the clock signal here? This is the clock. This is the clock signal, right? This is the analog. So this the output of this analog signal segment is sent to A to D converter. Means that means from this analog to digital converter, right? In this one, this happens A to D converter, A to D conversion. The output is equally spaced digital signal. Means you can get the output equally spaced digital. The next, see here, digital to analog conversion. Same. Here I told you that this is the digital, right? This is digital. Again, it converts to analog signal. Now you got my point, right? See here, this is analog signal, right? And it is converting into digital signal. Here it is. So digital, and again it is converting to analog. So what I said to you in the industry, we have to go for ADC and DAC. So that means the output of the DAC, that is the digital to analog, is fed to the actuator. There, the actuator actuates correctly. So we can get the output correctly. Here in this, the analog samples at the output of the DA converter is usually fed to sample and hold circuit to obtain the staircase waveform. Staircase, this is the staircase. And in which way it will obtain? So sample and hold circuit. Already we discussed in the previous slide. This waveform can then be filtered to obtain the smooth waveform. We can get the smooth waveform, this color. The analog signal here is different, and then here we can get the smooth wave. That means the corrected. If there is any errors, there is an incorrect in the signal. This the output of this signal is almost all correct. Say correct signal. So that means this waveform can be filtered. So here, filtered is nothing but it is we can go for only in signal conditioning mode. To obtain the smooth waveform shown in color. What is color? Here, blue color. The time delay usually introduced by the filter is not. Actually, it is not filter. How much time it will take from analog to digital conversion and digital to analog conversion. Lastly, we can get again analog signal. That analog signal we have to feed it to the actuator. Analog signal means it is in the form of electrical signal only. That electrical signal we are giving to the actuator to activate any element. To activate any element. Now you understand, right? Here the output is very accurate. That's why we have to go for ADC and DAC for industry purposes. Next, here see, if you clearly see, the heart of this data acquisition device is what I told you, the data acquisition system, right? I will show last, just I will show you so that you can understand what we discussed in the last class. Clean block diagram, I will show you. One minute. 'So here, in this data acquisition, now you clearly observe in data acquisition, what is their signal conditioning, ADC and DAC. Already last class we discussed. So what is this here? The heart of this data acquisition is nothing but ADC or DAC or the combination of these two. Sometimes we can use up to ADC only, I told you. Sometimes we can use both. Combination of these two. Means the heart of the data acquisition device is, even in the syllabus also, here it is clearly mentioned in the, see, in the syllabus also it is mentioned clearly. See here in the data acquisition system, analog to digital and digital to analog. Today we are completed up to this. It means the heart of the data acquisition system is, actually the data acquisition system signal conditioning is also there. That means one element in the signal condition, maybe amplifiers are there, filters are there, or attenuators are. According to our requirement, we can use that components to make the signal correct. Then another in data acquisition system, to what are the ADC and DAC, analog to digital conversion, digital to analog conversion. Means the heart of the data acquisition system is ADC or DAC or the combination of this. Okay. See here. Right. ADC, DAC, that means signal conditioning, ADC, DAC. This is the data acquisition. Now we have to go for so now this one. So already we discussed this one, right? Right over. The heart of the data acquisition device is a digital to analog converter. See here, if you see clearly, right? Digital to analog converter and also analog to digital converter, or the combination of these two, right? So don't forget, right? Now analog to digital conversion has a finite list of values which represents voltage. That means finite list of values. Analog to digital conversion, sometimes it represents this list of values represents, it is in the form of a binary, that is 0, 1. That is nothing but a voltage. That lastly we can get the, for example, that digital system. Here this is the input of this electrical form voltage. Then automatically we can get that parameter in the numerical number. So these are all things. And the alternative DAC can produce analog voltage. That means DAC produces analog signal. Analog signal, that signal is in the form of an electrical signal. This is a list of binary values. From a list of binary values means from here, from a list of binary values means digital, from digital to analog voltage. That means from a list of binary values to analog voltage. That means we can call it as analog electrical signal. Analog signal simply. The voltage generated by DAC stays the same until it receives another value from the computer. So whatever the output from the DAC, it is not given to the activator, it is still continuous till another value comes from the DAC again. Computer means here digital system. From digital system again, that input is given to DAC, digital to analog conversion, and then next the output of the DAC is given to the activator. In order to acquire to produce analog waveforms, DAC, ADC must activate the processor. That means according to our requirement, this analog to digital or digital to analog will vary. The converters, data converters will vary. So, okay, right. Today the topic ends, right? Today we discussed about ADC and DAC. Almost all in the syllabus, we completed 50%. Only another 2 classes left to complete this unit. Very simple. Last class we have to go for revision, and the next from 3 o'clock onwards, quiz is will be in the online. All of you attempt. Last quiz only 40 members are attempted. It's not correct. So wait for 2 minutes. I will take the attendance. All of you respond your attendance one by one. One minute. Number 3 1 minute. 1 minute. ఇంకోటి ఏంటంటే one thing. So those who are free, they have to come to the college and submit your mother Aadhaar card Xerox. Fast within 4 or 5 days kalla మీరు చూడండి వచ్చేటట్టు. You have to come to the college person physically. You have to give your Aadhaar card Xerox for applying scholarship. Those who are absent, better inform to them. right? Are you understand? You have to already you given the data, but here you have to come and then you have to write down that format, your name and your roll number, and then your Aadhaar number, and then your mother name, mother Aadhaar number, and then next we have to sign your signature is needed, right? So within 3 or 4 days, I advised to all of you, according to your convenient time, you have to come to the college and then you have to fill that format and then submit your mother Aadhaar card xerox, your mother Aadhaar card xerox. Then you have to sign it in the DU, right? DU is having that format already given to him. You have to come and then you have to write down in the format. Then you have to give the mother Aadhaar card xerox. Okay, remember this one. Now it is clear. The next number one, 4, 5, 7, 8, 9, 8 option. 9, 10, 10, 10. Right, plus 11, 13, 11, 11 options. 14, 15, 16, 17, 17, option 17, 18, 19, 20, 21, 15 present, okay. 21, 20 option, 21 present, 20 option. Right, 17 present, right. 21, 22, 21 present, okay. 22, 22 option, 23, 24, 25, 26, 27, 27, right, 27, right, 28, 29, right, 30, 30, okay, 29, okay. 32, 31%, 32, 33, 34, 35, 36, 37, 38, 39, 40, 40, 40 option number, 41 present, right, 42, 43, 43, 44, 45, 46, 48, 49, 48, 49, right, 50 present, 52, 54, 54, 55 present, okay, right, 54, 55 present, 56, so 56, 60, 61, 61, 61, 61 option, 61 option, 63, 63, 63, 64, 64 present, 65, 66, 66 this option, 67, 68, 69, right, 70, 73, 74, 75, 76, 77, 77, okay, right, 78, right, 81, 83, 84, right, 17%, 84, 85, 86, 88, 88, 89, 90, 90, 91, 92, lateral entry 1, right, 1, 2, right, present 3, 3, 3, 4, 5, 6, 6, 7, 8, 9, 9, 10, okay, right, 8, 9 option, 7, 8, 9 option, 10, 11, okay, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 23, lateral entry 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 31, 32, 33, 33, 33, 34, 35, 36, 37, 38, 39, 40, 41, 40, 41, 41 option. Let's see the option is 1 minute. 1 minute. 1 minute. 1 minute. 8 option is 8. 41%. 8, 11, regular 8, 11, 22, 32, 40, 48, 49, 56, 60, 61, 63, 66, 67, 70, 73, 74, 90, 92. Lateral entry 6, 7, 48% amount. Right, 48%, 49 also present. Right, 66, 66 present. So here again I'm repeating. Absentees are 8, 11, 22, 32, 40, 56, 60, 61, 63, 67, 70, 73, 90, 92, lateral entry 6, 7, 8, 9, 8, 9, okay, 23, 24, 32, 34, 35, 36. Okay, here 67, 17, 17 batch, okay, and 33 already present, 33, 33%, 73, okay, 73, okay, 70, okay, no, okay, okay, thank you all.